The arrival of 3I Atlas, a cosmic enigma. For decades, astronomers have scanned the dark expanse of space, charting comets, asteroids, and cosmic drifters. But every so often, something appears that does not fit the mold, an object that challenges the very boundaries of human understanding. 3I Atlas is one such object. An interstellar traveler, speeding through our solar system on a hyperbolic trajectory, unbound by the Sun's gravity. It is officially known as the third confirmed interstellar visitor, following in the footsteps of Oumuamua, 1I, 2017 U1, and 2I, Borisov, 2019. When it was first detected, astronomers were intrigued by its extraordinary speed and direction, but soon, their curiosity turned into disbelief. 3I Atlas did not behave like a simple comet or asteroid. It carried with it massive, unknown objects, mysterious companions that appeared to move in association with the main body. The discovery sent ripples through the global scientific community. Could this be a natural phenomenon, or something far stranger? Was 3I Atlas merely shedding fragments, or was it accompanied by co-travelers, possibly satellites, or even remnants of a once larger system? Telescopes across the planet turned toward this visitor. Networks like the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile began tracking its every motion, capturing images that defied conventional explanations. The data showed that these unknown objects were not just dust clouds or debris, but large-scale anomalies, distinct, massive forms, either orbiting or traveling alongside the main nucleus. The implications were enormous. One theory suggests that the primary body might be shedding enormous fragments, giant chunks of rock and ice breaking free as it warms under the sun's light. Another proposes that 3I Atlas is part of a binary or multi-body system, with smaller companion masses orbiting it, something never before recorded in an interstellar visitor. Even more provocatively, a few researchers have speculated that the unknown objects could be non-natural structures, dense, possibly engineered aggregates bound to the main nucleus. While such notions remain highly speculative, the very suggestion underscores how unfamiliar this event truly is. Estimates suggest the nucleus itself may span over 5.5 kilometers in diameter, far larger than typical solar system comets. Its trajectory indicates a deep space origin, moving far too fast to have been captured by the Sun's gravity. Yet, the presence of secondary bodies raises an entirely new layer of questions. Could this interstellar visitor once have been part of a planet-moon system, torn away by gravitational tides from its home star? Or might it represent the remains of a debris cluster, flung into the void by some ancient catastrophe? Every observation adds to the intrigue. The composition of 3I Atlas doesn't perfectly align with that of solar system comets. Its volatile materials, dust grain properties, and light emissions seem subtly alien. Spectral readings hint at chemical ratios not commonly found in our local neighborhood, suggesting formation under very different conditions. If these companion objects are fragments, they may tell a story billions of years old, a tale of formation, collision, and ejection from a distant star system. But if they are bound companions, then we may be witnessing something unprecedented, a multi-body system traveling through interstellar space, intact. This idea stretches the imagination. For such a complex structure to survive ejection from a planetary system, and journey across light years of turbulence, radiation, and cosmic collisions, it must be remarkably stable and ancient. And now, it has entered our solar system, giving humanity a rare opportunity to study a foreign world without ever leaving home. The arrival of 3I Atlas marks not just another discovery, but a new chapter in the story of cosmic exploration, one that may force scientists to redefine what they know about comets, companions, and the architecture of other planetary systems. The companions and the cosmic implications. Since its detection, observatories across the globe have mobilized in coordinated effort. From Earth-based telescopes to space observatories like the Hubble Space Telescope and the James Webb Space Telescope, every available instrument has been aimed at this interstellar visitor. Spectrographic data, infrared readings, and long-exposure imagery are being analyzed to isolate the main nucleus from its mysterious companions. But the task is far from simple. The secondary objects are faint, distant, and moving unpredictably. Distinguishing between true companions and optical illusions caused by dust or lensing requires precision, patience, and high-level modeling. The goal is to answer key questions. Are these objects gravitationally bound to the main nucleus? Are they fragments that separated during ejection, or are they ancient moons, still in orbit after billions of years of travel? Do they share the same composition, or do they tell different chemical stories? If the companions differ in makeup, it could mean that 3I Atlas once orbited a star with multiple planetary zones, each producing distinct materials. Studying these variations could provide an unprecedented glimpse into the formation of alien planetary systems, their chemistry, their physics, and their histories. The implications stretch beyond science. For planetary defense experts, the event is a timely reminder that interstellar bodies can arrive unpredictably. Though 3I Atlas poses no threat to Earth, its sheer size and complexity demonstrate how diverse and potentially dangerous interstellar objects might be. Philosophically, this discovery is equally profound. It reminds us that our solar system is not isolated, it is porous, connected, part of a living galaxy filled with migrating bodies, drifting clusters, and long-lost fragments of other worlds. We are not merely observing space, we are witnessing the exchange of material between stars. Some astronomers have speculated that interstellar clusters like 3I Atlas might carry complex organic molecules, even prebiotic compounds, across the galaxy. If so, they could be vehicles of cosmic panspermia, seeding planets with the raw ingredients of life. Whether or not this is the case, the possibility gives this discovery a poetic weight. In a more practical sense, this event will likely redefine how future missions are designed. Should humanity ever attempt to intercept or study an interstellar object up close, spacecraft will need to prepare for multi-body systems, clusters of debris, satellites, or fragments, not just a single nucleus. 3I Atlas is teaching us, in real time, that the universe is more complicated than our models once assumed. Every image captured, every data point recorded, is a piece of a vast cosmic puzzle. The system's brightness, its tail dynamics, its subtle wobbles in trajectory, all point toward a universe where solitary travelers may be the exception, not the rule. In the end, the discovery of massive unknown objects associated with 3I Atlas is not just an astronomical curiosity. It's a profound reminder of cosmic diversity, of the endless ways matter can form, interact, and travel between stars. Perhaps our galaxy is filled with such celestial caravans, drifting through the void, carrying with them fragments of forgotten worlds. For scientists, this is a golden opportunity. For humanity, it's an invitation to look deeper, to think broader, and to remember that even in the vast emptiness of space, we are connected by the silent journeys of wandering stars. 3I Atlas and its companions may soon fade back into darkness, vanishing beyond the reach of our instruments. But their story, the mystery of their origin and the clues they carry, will linger, reshaping how we understand the grand exchange of matter across the galaxy. In these massive unknown objects, we glimpse not only a visitor from afar, but a mirror of our own cosmic origins. A reminder that in the dance of stars and debris, we too are travelers, briefly illuminated under another sun's gaze.